Okay, so this is take 2 because the last one I did was blurry. So I'm gonna try this again and hope that this video turns out less blurry. Here we go, keep your fingers crossed. So this is a review for the quiz on sections 1 through 4 of chapter 13. So you may want to take notes to help you remember what to study, or however you want to do this. So first thing you have to know, the big thing is you have to know those exact values. Hopefully you've been studying them, you've made your flashcards, you've got them down. So let's see who knows their exact values. So you need to make sure you know. And what are the 3 big angles you need to know them for? That's right, 30 degrees, 45 degrees, 60 degrees. You might have to know them in radian mode. What is 30 degrees in radians? Good, pi over 6. What is 45 degrees in radians? Pi over 4. What is 60 degrees in radians? Pi over 3. So you need to know the big 3, sine of the angle, cosine of the angle, and tangent of the angle. So let's see who knows those without looking. What's sine of 30 degrees? 1/2. What's sine of 45 degrees, or pi over 4? Root 2 over 2. What's cosine of pi over 3, or 60 degrees? Root 3 over 2. What are the cosine values? That's right, they flip. So root 3 over 2, root 2 over 2, 1/2, or I should say they reverse order, not they flip. And then tangent, how do we get tangent if we forget? Good, we can divide sine by cosine. So what's 1/2 divided by root 3 over 2? It ends up giving you root 3 over 3. What's root 2 over 2 divided by root 2 over 2? Gives you 1. And what's root 3 over 2 divided by 1/2? It simplifies to give you root 3. So these are the ones you have to have memorized. Do we have to memorize cosecant, secant, and cotangent? No, you just need to remember that cosecant is the reciprocal of sine. So cosecant of 30 degrees would be 2. Good. You also have to know your quadrantal angles. What are quadrantal angles? Quadrantal angles are the ones that land on the axes. We begin at 0 degrees, which is 0 radians. What's this angle? 90 degrees, which is pi over 2. What's this angle? 180 degrees, which is pi. What's this angle? 270 degrees, which is 3 pi over 2. And then we're back to 360, which is 2 pi radians. Good. On this unit circle, if it has a radius of 1, what is this coordinate right there? In x and y, what would that coordinate be? X would be 1, y would be 0. If the radius is 1, what's that coordinate? 0, 1. If the radius is 1, what's that coordinate? -1, 0. And if the radius is 1, what's that coordinate? 0, -1. This is helpful because sine and cosine and tangent all use the x and y coordinates. So if I wanted sine of pi over 2, well then I would just be sine of pi over 2 is y over the radius, where the radius is 1, so it would be just whatever y is, which is 1. So it will be whatever the y is, and since the radius is 1, it's just going to be y. Cosine we get by looking at x over the radius, but if the radius is 1, it's just going to be whatever x is. And tangent we get by doing what? Whatever y divided by x is. So for 90 degrees, sine would be the y coordinate, 1. Cosine would be the x coordinate, 0. And tangent would be 1 divided by 0, which is undefined. How would I get cosecant? Well, cosecant would take whatever sine is and take the reciprocal. Secant would take the reciprocal of whatever cosine is, and cotangent would take the reciprocal of whatever tangent is. So go back and study that. And then the last thing, as we move around the quadrants, we need to pay attention to if they're positive or negative. What helps to remember that? All students take calculus. What does the A stand for? All the trig functions are positive in the first quadrant. What's the S stand for? Sine is positive in the second quadrant. That means cosine and tangent are what? Negative. T stands for tangent is positive in the third quadrant, so who's negative? Sine and cosine. And in the fourth quadrant, cosine is positive, so who's negative? Sine and tangent. Good. You need to be able to find coterminal angles. So you need to go back and refresh your memory. What's a coterminal angle? You'll need to be able to give me a positive and a negative one. And you're going to need to be able to do it in degrees or in radians. I might do one of each. I don't know yet. But you need to be able to do both. And you need to give me a positive coterminal angle and a negative. You need to be able to find reference angles. And again, those reference angles might be in degrees, but they might be in radians. I'm going to do all of it. So make sure you know how to get a reference angle. What is a reference angle? It is an acute angle, that means less than 90 or less than pi over 2, and it's the distance from your terminal side to your x-axis. So over here, it's how far you are from 180. So these would be reference angles. Over here is also how far I am from the x-axis. So for down here, it would be how far I am from 360. In radians, it's how far I am from pi or from 2 pi. And then you need to be able to convert from degrees to radians. How do you convert from degrees to radians? So if I start with degrees, how do I turn it into radians? I multiply the angle in degrees by pi over 180. And you need to be able to convert from radians to degrees. How do I do that? I start with my radian angle and multiply by 180 over pi, and that will give me my degree angle. So let's do a quick example practicing these three things. We're going to do a degree example first. So if you're given 100 degrees, find two coterminal angles for me. I want a positive one and a negative one. Find the reference angle for me, and then convert it to radians. So how do I get the coterminal angle? Now you might want to pause the video, try these, and then check my work. But I'm going to go ahead so I'm not just standing here quiet while y'all are working it out. So coterminal angles, well, 100 degrees is located right about here. So coterminal means I need to figure out how I can get to the same spot. Well, one way is I can go the negative direction. How would I get that? I would do 100 minus 360 and get negative 260. Another option is I can go the positive way with an extra loop. I would get that by doing 100 plus 360, which is 460. And so I've given my two a negative one and a positive. How do I get a reference angle? Again, I draw where it's located, and I need to figure out how far it is from the x-axis. How far is 100 from 180? It is 80 degrees away, so 80 degrees would be my reference angle. And finally, how do I convert to radians? I multiply 100 degrees by pi over 180. I like to cancel my zeros. What number goes into 10 and 18? 2 does, so I get 5 pi over 9. Let's do one in radians. So let's suppose I start with negative 4 pi over 3, and I want to do all the same things. So again, pause your video, find the coterminal angles, the reference angle, and convert it to degrees, and then check your work with mine. So for coterminal angles, I like to draw a picture. Negative 4 pi over 3 means that a mixed fraction would be negative 1 and 1/3. So I go to 1 pi and then 1/3 of the way to another, which would give me, I could go this way. How far would that be? That would be 2 pi over 3. Or I could do the negative way with an extra loop, or that would be 2 pi and then another 1 and 1/3, which is 3 and 1/3, which is negative 10 pi over 3. Now, you may say, well, that was a little hard for me, Ms. Conrad. So you could just simply say, I'm going to add 2 pi and I'm going to subtract 2 pi and get the same answers. I need a common denominator. What's the common denominator? 3. So I'm going to add 6/3 to -4/3 and get 2/3. I'm going to add subtract 6/3 from -4/3 and get -10 pi over 3. Reference angle, I'm going to find my location again. So -1 1/3. The reference would be the distance from here to here. How far is that line from pi? It was 1/3 pi away, so pi over 3 would be my reference angle. And finally, how do I turn -4 pi over 3 into degrees? I multiply it by 180 over pi. What happens to my pi's? They cancel. 3 goes into 180 how many times? 60. 4 times 60, or -4 times 60 is -240 degrees. Good. So let's move on to what else you need to know for this quiz. Okay, so you need to know how to find 6 trig functions given a point on the terminal side. And for this example, the terminal side you're given is, or the point you're given is -2, 3. So what's the first thing you need to do? First thing you need to do is figure out where this is located. So where is -2, 3 located? That's right, second quadrant. So I went 2 to the left, 3 up, and I made myself a triangle so that I can find my radius. Because in order to find the 6 trig functions, I need to know x, I need to know y, and I need to know r. So how do I get that r value? I use Pythagorean theorem. So -2 squared plus 3 squared equals r squared. So 9 plus 4 is 13. So square root of 13 is my radius. Remember, radius is always positive. So now that I know my r, I know my x, I know my y, I can get my 6 trig functions. Because what does sine always equal? Y over r. So in this problem, that will be 3 over root 13. Can we leave it that way? No, we have to rationalize it and get 3 root 13 over 13. What does cosine always equal? That's right, x over r. So we get -2 over root 13. Again, we have to rationalize it, so -2 root 13 over 13. What does tangent always equal? That's right, y over x, so in this problem would be -3 over 2. But there's 6 of them. So we have to remember the reciprocals. What's the reciprocal of sine? That's right, cosecant. I think it's easiest to flip this one because then I don't have to rationalize anything. So root 13 over 3. What's the reciprocal of cosine column? Secant. And that becomes -root 13 over 2. And finally, what's the reciprocal of tangent called? Cotangent, -2 over 3. Good. Something else you need to know how to do for the quiz is you need to know how to find exact values for any angle around the unit circle that has a reference angle of 30, 45, and 60. So we need to find exact values. Okay, so for example, sine of 300 degrees. Again, try it and then watch my work instead of watching my work before you've thought about how to do it. So the first thing you do is you find your location. I'm in the 4th quadrant and I need my reference angle, which is 60. So then sine of 60 you should have memorized. It is root 3 over 2. So it is root 3 over 2. And then last thing you decide is where am I located? Is it positive or negative? All students take calculus. I'm in the cosine corner, so what will sine be? Negative, so I have to make it negative. So I want you to try cosine of 135. Freeze your video. So I'm going to work it out. You should have already tried this when you froze your video. My reference is 45, which is root 2 over 2. And then based on location, all students' cosine should be negative. So now let's try some radian ones. tangent of 2 pi over 3. Look where you, again, freeze your video. Try it out. So 2 pi over 3, 2/3 of the way to pi puts me in the second quadrant. So what's my reference? Pi over 3. What's tangent of pi over 3? That's one of them you're memorizing. It is root 3. And then all students, so what should tangent be in that quadrant? It should be negative. Good. Another one, cosecant of 3 pi over 2. Who has cosecant memorized? Not me, but what do you have memorized? Sine. So we're going to find sine of 3 pi over 2. So first, where is 3 pi over 2 located? That's right, it's on the axis. This will be 1.5. I'm right here. That means on this circle, I just need to know what that point is. What's that point when the radius is 1? 0, -1. Sine is which one of those? The y coordinate. So sine is -1. But we wanted cosecant, so what do we do to that answer? We take the reciprocal, and the reciprocal is -1. And we'll do one final exact value and move on. Secant of -5 pi over 6. How many of you have secant memorized? Not me. What's the reciprocal called? Cosine of -5 pi over 6. So first, again, please freeze your video and try this, and then check it when you're done. So cosine of -5 pi over 6. 5 pi over 6 negative means I go clockwise. Where do I end up? Well, if I'm going 5/6 of the way to pi, if I've got 5/6 of a taco to eat, I'm going to eat most of it. Maybe I shouldn't, but I'm going to. And then how much taco do I have left over? I have 1/6 left over, so that is my reference angle. What is cosine of pi over 6? It is root 3 over 2. So this will also be root 3 over 2, but then we look at location. All students take, I'm in the tangent corner, so what will cosine be? Negative. Am I done? No, because I want secant. Well, what does secant do to cosine? It's the reciprocal. So we're going to flip that and become -2 over root 3. Can we leave it like that? Nope, got to rationalize it. We get -2 root 3 over 3. Good. So then we move on and review all the different triangle problems you did. In section 1, we did right triangles. What do you use for right triangles? That's right, SOHCAHTOA. So make sure you go back in section 1 and look at all the different word problems that we did and different right triangles. We did some things that came up. You need to know what angle of elevation is versus angle of depression. So look at, or descent. Some people say descent. Look at those. Make sure you know how to find angle, the angle. So let's suppose this were my right triangle, and I want to find that angle. It'd be opposite of hypotenuse, so sine of the angle equals 2 over 7. But how do we put it on a calculator when the angle is what we don't know? That is when we use the inverse button. So it will be sine inverse of 2/7 equals theta, and that will give you your angle. For all of the triangles, you should be in degree mode. So make sure you review the word problems from 13.1 where we had to use SOHCAHTOA. Those would be good ones to look back at, and make sure you're in degree mode anytime it's a triangle problem. You will have some problems where you have to use your calculator and pay attention to mode. So if I asked you to find cosine of 7.2, what mode should you be in? That's right, you need to switch your calculator to radian mode because there's no degree bubble, and then just hit your cosine button and you'll have your answer, but you have to switch the mode first. What if I asked you to get cosecant of 24 degrees? Well, first, what mode should you be in? You should be in degree mode. And then, once you're in degree mode, push this cosecant button. Uh-oh, wait a second, there's no cosecant button. Does that mean I use sine inverse? No, sine inverse is for when the angle's not known. How do we put cosecant on our calculator when there's no cosecant button? It's the reciprocal, so we do 1 over sine of 24 degrees. So make sure you study that. And then finally, the last thing you need to know how to do is section 13.4. How do you get the area of a triangle when you don't know the height? Remember, it was 1/2 side times side times sine of the included angle. Okay, so in other words, if I know this side is 3 and this side is 8 and this angle is 40 degrees, how would I get the area of that triangle? It would be 1/2 3 times 8 times sine of 40 degrees. Make sure any triangle problems you will be in degrees. That doesn't change. And then you need to know your law of sines. This is the ratio law. So sine of A is to side A, as sine of B is to side B, as sine of C is to side C. Any of those ratios are equivalent. But remember, you need to know how to, if there is one triangle possible, no triangle possible, or 2 triangles possible. Remember, this is called the ambiguous case. Go back and look at your notes about how to tell if it's going to be 1 triangle, no triangles, 2 triangles. You have to check the angle you find and see if the obtuse supplementary option can work as well. If the obtuse supplementary option is too big, then you don't have a second triangle. But if it's not too big, then you have to give me both triangles. So this is what you need to study. Let me know, email me if you have any questions before you take your quiz that you need to ask me about.